Hello everyone, in this session we'll be running all the load store instructions along with the pseudo instruction that we discussed in the theory session on Keil, okay, and see how it works, okay. So let's start here. The very first instruction you see is actually a pseudo instruction, and as per this particular instruction, this hexadecimal value, which is of 32-bit, should be loaded to register R3. Let's see if that happens. Yes, R3 gets the new value. Okay. The next instruction we have is value 1, which is nothing but a label here, okay, belonging to read write section, and it has some initial value 0. We want the register R2 to be pointing at this particular memory location. What it actually means is value 1 is actually a label which marks a specific memory location. So it will have certain numeric values. When this instruction is executed, that value is loaded to R2, and then we can actually access that memory location using a memory window. Let's see that happening. Yes, so 4000 is the memory location. Fine. And one thing you should know here is this is the initial location 4000. These, as we move towards the right side, the memory address increases. Okay. So what we are trying to do next is we want to store a byte of data which is present in this particular data, okay, into the location pointed by R2. If this is the original data, if you want to only store 8 bits of data, that is 1 byte, it will be the least significant byte from this, which will be copied to the location pointed by R2. In the sense, 88 should appear in this particular memory location. And now you see that happening. Next, what we want is store half word, 16 bits of data from this particular hexadecimal data should be copied into the location pointed by R2. Now location pointed by R2 remains same. What do you mean by 16 bits? This constitutes 8 bits because each hexadecimal digit is made up of 4 bits. So this constitutes the 16 bits. How will you write it in binary? It will be nothing but 0 1 1 1 0 1 1 1 1 0 0 0 1 0 0 0. So this is 4 4 here 4 4, total 16 bits, right? Okay. So now let's just continue. So we have this particular instruction. What it should do is 7788 should be placed here, but because here address increases in this particular fashion, that is from left to right, and since this is a little Indian system, we are using LPC2148, okay, that's why when this particular loading happens, 88 will remain here, 77 will be loaded in this particular position or copied to this particular position. Let's see that happening. Okay, 8877. Next, what we have is store. So obviously 32-bit data from here should be copied to this particular location. What is 32-bit data? It will be all this data combined together. Each digit 4 bits means 4 into 8 is 32. So you will get 88776655 here. Let's see that happening. Yes. Okay. Now what I want to do is I want to see how load instructions work. The very first instruction is load, but just 8 bits of data from the memory location pointed by R2, which is still the same, okay, that is this location itself. Fine. I want to copy the content which is present in this particular memory location, but only 8 bits. So which 8 bits will be copied? The least significant byte, that is 88, will be copied into register R1. So this will be 88. Yes, we see that happening. Next, we want to load 16 bits or half word. So what do you mean by half word? This and this should be combinedly placed in register R1. Let's see that happening. Okay. Next is slightly different. Okay. We have signed byte and signed half word. What do you mean by signed byte? Now we know byte, it will immediately locate this particular value, that is 88. So how will you write 88? It is something like this. This is the byte that we want to place in the register R1, but we want signed byte. Signed byte means you have to check this particular bit, that is MSB bit of this particular 8-bit value. If it is 1, then all these bits will be filled with 1. Okay, so this is the final answer you should expect, because MSB bit here is 1. Let's see if that happens. Yes. So next what we want is, we want to load half word from here and place it in register R1, but after sign extension. So what will be the half word that will copy? 7788. Why am I writing 7788 instead of 8877? Because of Little Indian system, lower memory address, whatever data is there, should be placed in least significant byte. Higher memory location, whatever data is there, should be placed in higher byte position. You expand this 0111, 0111, 1000, 1000. Okay. So now what is the MSB bit? 0. So all this remaining bits will be filled with 0. Okay. So this will make our final answer something like this. Okay. Let's see that happening. Yes. Okay. Next, let's go to our next instruction. We want R6 to point at the memory location defined by the label initial. What is initial? We have initial is a label which points at a memory location which has this particular data. Okay, and one thing you should remember, this is in read-only area. Okay, so you can't modify this content, but you can access that particular memory location and read what value is present there. Okay, let's do that now. Now R6 will be pointing at this particular memory location. So let's see what exactly is that memory location. 5C. Okay, so you can see that in the memory location 5C, okay, which is the actual memory address defined by this label initial, the value ABCD12FF is stored. Okay, as expected, the least significant byte is in lower memory address, and as address increases, you can see the other bytes placed. Okay. Now, I am performing LDR. Okay, so what it means, copy 32 bits of data from this particular location and place it in R0. So because R6 shows the address of label initial, okay, which is 5C, if you try to access that particular memory location and load 32-bit value, this exact content should be copied to R0. Okay, let's see that happening. Okay, next what we are doing is, we are actually giving the memory address 4, all zeros and 8. Okay, here I'm using a memory address greater than 4 and all zeros only. I'll show you later on why exactly is that. This instruction just copies that value into R4. Now let's see this particular instruction getting executed. Okay, so next what we have is store R0, whatever content is there in the memory location pointed by this. What memory location are we speaking about? 4, all zeros and 8. Okay, initially in that particular memory location there is no value stored. We want to store R0. What is R0 value? R0 value is this A, B, C, D and all that. This from this value just a byte, that is last FF, I want to store in this particular location. Let's see that happening. Okay. Next, what I want to do is I want to store 16 bits. So this will remain same. 1 to FF should be now pasted in this location. Let's see that happening. Yes, that is copied. After that, I want to store the entire data here. So let's see that happening. Yes, that value is copied. Okay. So now I'm just trying to copy the entire data into register R5. So what I have to do for that, just use LDR. Okay. Now I'll show you the memory alignment issues happening. I have chosen a memory address here. See, here I have chosen a memory address which is divisible by 4, divisible by 2. So store or load will not have any problem, whether it is half word, whether it is 32-bit, no issues. For byte, there will be no issues loading or storing. Okay, even if you access any odd position. Okay, but here I'm choosing an odd position, so LDRB should work, STRB should work, but these should cause alignment issues. Let's see that happening. Okay, so first of all, I've loaded the value 4 and all 0 1 into R4. So the very first thing I'm doing is 4001. What value is there at 4001? 77, 66, 55. Okay, this value I want to copy to R5. That is possible, no issues, because we are speaking about byte. Okay, so any byte can be accessed in the read write memory area. Okay, but what about the next case? You get this issue, non-aligned access ARM instruction, okay, at this particular location, and memory access at this particular data. Why is it not possible? Because for half word load or store, the memory address that you are choosing should be divisible by 2, or in short, it should be even. Okay, what about the next instruction? Will that, and if you see here, okay, you got some answer in R5 which is actually a wrong answer. What you should actually get, should get these two values, that is it should be 6677 here, but you got a wrong answer. Okay, now let's just continue. That is nothing but we want to load 32-bit data from here, from this location. Is it possible? No, because for LDR this particular address should be divisible by 4. Okay, let's see what answer you get. You get again non-aligned access issue here. Okay, and even the value which is copied after this instruction, what should have actually been copied? 00556677, but what you get is 88556677. Okay, which is not correct. Okay, again I'm trying to store a byte of data from R5 to R4. So if you see this particular case, that is in R5, the byte which can possibly be copied is 77, and I have to place it in this location. Actually that works. Okay, there is no issue with that. You don't see any issue here or any warning here. But what about the next instruction? I'm trying to store entire this 32-bit in this particular location. Let's see what happens. Okay, you got wrong answer here first of all. Okay, and you can see non-aligned access issue or warning shown here. Okay, so these were few things you need to know in load store instructions, and also about the pseudo instruction LDR RD comma equal to some constant. One thing I wanted to show here is when I click target, options for target, okay, I can see here something like read write memory area and read only memory area. As you can notice here, my read write memory area starts from some location 0x4 and all 0. That's the reason when I try to access a memory location to store some data, then I'll use values like 0x4 and any number above it. Okay, and if you're choosing labels, then automatically they will be stored in location which comes in read write memory area only. Okay, in this particular case the label comes under read only section, so we can't modify the content. Here it comes under read write area, so you can store and load the values. Here you can only load the value.